it's now time to look at a few cube root graphs. Just like the square root graphs, I'll show both methods, both plotting the parent and shifting points individually, as well as starting at the turning point, and from the turning point using the pattern to find the rest of the graph. Both methods work, although the latter method is a bit quicker. So let's start here, number 11. We've got a cube root function, and with that cube root function, we get a couple of transformations. Ooh. My first transformation, the one on the outside, is up 2. Our entire parent graph is going to shift up 2 units. The plus 3 on the inside tells me we're moving to the left 3 units. So keep in mind the parent cube root function, now we're looking down here, our parent cube root function has both stuff going to the right and to the left. It kind of looks like 2 square root functions stuck together end to end, albeit a little smushed. So that's going to be our parent graph. I will graph one of these using both methods, so we'll go ahead and start with the parent graph method for this one. I can start with the parent graph, which has points at 0, 0, 1, 1, 8, 2, and then also the negatives, -1, -1, as well as -8, -2. That was our parent graph. You don't have to draw that dashed line in if you don't want, but it's going to help me actually move everything around. From that parent graph, we're going to move every point left 3 and up 2. It's probably easiest to start at the origin, left 3 and up 2. That's going to be our new point. We're going to do that with every point, left 3 and up 2. As we continue on, we have a left 3 and an up 2. Jumping over to the left side, looking at some of our negative numbers. Let's see, getting hard to see some of these. Left 3, there we go, and up 2. And then we have one that's going to wind up just off the graph a bit. Left 3 and up 2. So that's one method to help you graph that cube root function, starting with the parent function and actually moving every single point. If you like that method, feel free. This one has the benefit of being very visual. You start with something and then clearly move each point in the same way. So it does have that benefit. The downside is the work is a bit messy, especially if you write everything out the way that I did. And also when we start playing with stretch, it makes stretch a bit more difficult. So let's start talking about domain and range. Well, notice I have arrows on both sides. So my domain, my x values, it's everything. And guess what? So is my range. A cube root function will touch every single x and every single y on the coordinate plane. It'll just take a while to get there. My endpoint, oh, it's a cube root function. It never ends. So instead we call it a turning point. It's no more difficult than the square root function. It's still just our h and our k value. Our h is -3 and our k is 2. We can also talk about end behavior, although it's not as interesting on a cube root function. As x gets really large, so does y. You throw in a big number, you're going to get back a big number. However, things change as we look to the left. Since there is no endpoint, we can actually go to -infinity on the left. But if you look at that arrow, it's slowly trending down. So we're going to go to -infinity for our y value as well. So the end behavior for a cube root function looks a little bit like the cubic functions that we did first semester. If you don't remember those cubic functions, a quick Google search, and you'll probably want to never look at them again. We don't talk about increasing and decreasing intervals at the AB level, but note that this function, as you look from left to right, it's always getting bigger, so it would be considered increasing all the time. But we don't have to worry about that for our class. Let's take a look at one that does have a stretch. And not just a stretch, but note that that -2 is going to cause a reflection as well. This is a great example of a problem where starting with the parent function is probably too much work because using the pattern is very quick, especially with that stretch involved. So I'm going to go that way. So this graph doesn't have an H or a K at all. It's a 0 and a 0 for our H and K. It's going to start right there in the origin. So that's great. Let's go back and actually look at that cube root graph and see the pattern. So as we're taking a look, our next point from the origin of the parent graph would be up 1 and to the right 1. It's difficult to see, but notice that that graph has a point up 1 and to the right 1, and from the origin it also has one down 1 and to the left 1. So we can use that same idea to help us sketch this cube root function, except instead of up 1 or down 1, I have a stretch of 2. So I'm going to go up 2 and down 2. Putting that together with the reflection, instead of going up and to the right, I'm going to go down and to the right. So I can stretch 2 and go to the right 1. On the other side, I can also move up 2 and to the left 1. Note that this graph will go low where the parent graph goes high, and it will go high where the parent graph goes low. Using patterns allows us to graph very quickly. Again, I'm making this graph just by looking at the parent graph and recognizing the pattern, the up 1, right 1, and down 1, left 1 pattern. So if you like that method better, it is quicker, and I do enjoy it. If you would rather actually transform every point, you can feel free to do that as well. The domain and range don't change here. It's still all real numbers. But the end behavior is going to flip-flop, and that's what's somewhat interesting. As x gets really, really, really large, keep in mind that's this arrow. As x gets really, really large, y is now getting really, really small. That's what a reflection does for us. We're going to get all those negative numbers when we put in positive x values. We also get a flip-flop on the other side. As x goes out to negative infinity, y will go off to positive infinity. So when I substitute in really large negative numbers, I'm going to get back really large positive numbers. So that's an interesting thing about this cube root graph. We'll take a look at 2 more in the next video. Definitely raise your hand and ask a question if you're lost or stuck on any of this, and let me know what you need.